Hello, this is a video about the adapter pattern, one of the gang of four software patterns. So the adapter pattern is a pattern that allows two incompatible interfaces to kind of work together. So often when we are developing something, we have different interfaces, but we want to interface in a similar way with these. So what we simply do is we try to convert the interface of a class into another interface that the client, that means the program we are using, actually expects. So generally, we just create another class that follows the interface and kind of translates from one interface to another. So here on source making is an example. So they use an example of different kinds of plugs where you can go from one plug to another plug. And I think I like this example where we have some kind of application, and this application uses some kind of wrapper to talk to some legacy component that does something else. So let's say that new application always tells things to do this, but the legacy component can only do that. So what the wrapper does is it creates just to do this, and then it does that. And I have a better explanation, I think, here. So this is an example of a test framework for different algorithms. Let me just briefly show you. You've seen it before, but let's do it again. So for example, we can take bubble sort and we can click start, and it will run bubble sort on different sizes of inputs. And this is just simple integers. And then we can see the time complexity of this. So we should see that it's n squared or something like that here. And then we can choose another one. For example, we can do the quicksort algorithm and see that it's extremely fast compared to the bubble sort algorithm, and that's even for much bigger inputs. So it's almost linear, but this is what the program is all about. It has nothing to do with the adapter pattern. What is interesting is that it's actually using another pattern, the strategy pattern for these different algorithms. So the way that algorithms are inserted is that there's this helper class called algorithm loader, which is just for convenience. And what it does, you set up here which algorithms that are going to be loaded. And by loading them here, they will automatically be set up in the GUI and also automatically loaded so that it will use that one when you try to click start. So the way that they work is that they all confine to this interface here, which is called iAlgorithm. And this is my colleague who created this. And iAlgorithm has a do work. It has something called get data, set input specification, get input specification. And it also has a special one that I added at some point called stop work, where we can kind of stop the algorithm from working as well. And that has translated into, he created another class called generic algorithm, and this class implements the iAlgorithm, has some basic features that is kind of set into it, like the name and the description and holding the data that we actually need to hold. And then it has some default value here for the inputs. So when we create a new class, if we extend this generic algorithm, we get all of this for free, and we don't need to specify that for ourselves. There's a bit of a problem here we need to fix, but that's okay. So what if I want to put another algorithm here? So the algorithms are already implemented. Let me show one of the algorithms. So doop, doop, doop. So there's the sorting here. So these are the sorting algorithms, and the one that I tried was bubble sort. So what we set up here, we call the superclass the generic algorithm with bubble sort, and then the description of it, and then which kind of algorithm it is. And then the next thing that we're doing is we have this do work where we do have this check to see if stop, then return. That means that we can stop this from running. So the next thing I want to do is I want to do some other algorithm. This is based on comparable. And if you look a bit into comparable arrays, you'll find that Java can also sort them. So what if I wanted to compare these algorithms, for example, bubble sort, against the one that they use in Java? So I could go in here and read the documentation. You can see this is the sorting algorithm, and it can actually choose. You can choose between some kind of legacy merge sort that they used before for comparables, or you can choose the TIM sort that they are using. So that would be something you would request if you wanted to. Otherwise, it would use comparable TIM sort. So what if I wanted to check if this actually was faster than the ones I implemented? So the problem is that I cannot use this directly in my system, because remember that I cannot do something like this. I cannot instantiate the sorting algorithm. And if we look in here, the comparable TIM sort is a package private class. So it's actually not meant to be used from the outside. Could do some reflection or something, but that would probably not be a very good idea. And if it updates in the future, it wouldn't be very good. So the only thing I can do is I can do something like this. I can say erase sort and then put in the array that I actually want to sort here. And this is an example with an integer array. Because integer uses comparable. That's what we were going to use here. So what I really want is I want something like algorithms dot add, and then I want to say new Java, what we call that, Java default sort, something like that. So this is going to be my adapter class. So what I want to do is, this is my wrapper class, and that wrapper class, of course, needs to adhere to the same interfaces and everything as brute sort and bubble sort, all of the other ones. So let me just try to create a class like that. So destination package. So I think visualize algorithms, business logic layer, algorithm, and this is also a sorting algorithm, so I'll put it there. Just ignore that for a second. And now it's called Java default sort. So it says it implements the AI algorithm. I actually want to use the generic algorithm instead, because that already implements the AI algorithm. So I'm going to say extends and then generic algorithm. We can see that bubble sort does this as well. In the constructor, we're going to do something like this. So we go in here, go in here, and then I want to create a constructor. And I'm just going to set that with a default like this, and then I'm going to put something like this. And of course, Java default sort. And then question mark, and it's a sorting algorithm. That was one thing. So I can see I need to implement some more stuff. So let's try to say implement methods, and I need only to implement the do work method. So this is pretty simple, although my stop work method can't be initialized. Let's just keep that out of it for now. So the do work method, this is the interface that I actually want. So there's an interface like all the others that my wrapper class wants to adhere to, and that is the iAlgorithm interface. And I'm doing that through the generic algorithm. So the Java default sort, so what I'm really going to do, I'm just going to take the data. So I'm going to say super get data. This is actually my data that's inside of my superclass, and we can see if we look at bubble sort that it uses comparable like this. So if we go back here, we can say comparable array. This is the one. Remove the comment. So now I have my array that I want to sort, and the only thing I'm going to say arrays dot sort, and then I can use just like this. This is the only thing that I need to do actually. Then it will sort the array. So we see that it's void. So it actually, because it's a simple data type, it actually moves everything around. So the array is not returned or anything like that. It's just sorted like this. So that it's not a complicated one, but this way I created this now. This is my Java default sort. It's actually my adapter class, and it extends the generic algorithm, and I use my do work method. So now I can use it like anything else in my system. I can remove this part here, which was just for comments, and then I can run my program and it fits. It should work. I can say Java default sort and start, and I can see that it's pretty fast. I can try bubble sort. Going a bit slow. So maybe I should have set it up like quicksort. So now if I want to compare with quicksort, I could go in here in my quicksort that I implemented here, and I can set the input specification here to something else. So I'll go here, so it's a lot bigger. And I can see that the largest element is around one second, and then I can go to quicksort and see that that was actually just a tiny fraction faster. So there's not a big difference between quicksort and then the default sorting in Java. Really, not in this test. Oh, there's some problem here. Need to fix that. Okay. Yeah, so that's basically how you use the adapter pattern. Another place where you can see the adapter pattern is also when you're working with databases, for example. There are some generic classes for handling database stuff in Java, and you can use these these are kind of adapter classes as well, because they can be used for any database type, so they're not dependent on a database. So let's try to see if I have a project here. Graphical department with persistence. DB transactions. Let's try this one. So in this case, let's go for count information. So what we can see here is that we have this DB connector, and it gets a connection. And if we look at this connection class, it's something under Java SQL. So these kinds of connections, we can get them from any kind of database. So this way we kind of wrap around that this is actually using a Microsoft SQL database. So you can see here we're using this Microsoft SQL Server exception. So, and if we go look inside of the DB Connect class, sorry, there are some login information. Other than that, we can see that it uses Java SQL connection and it uses the Microsoft SQL Server driver. So this is where the SQL Server data source comes from. So actually what we can see here is that the SQL Server data source actually gives us with this connection, it gives us a Java connection. So the connection interface is kind of like an adapter for any SQL Server data source. This is a special case, though, that the SQL Server data source itself provides this kind of adapter or common interface for working with it so that it works with the native Java SQL stuff. So that's it about the adapter interface.